Good afternoon, everyone. Welcome to this session of creativity, innovation, and inventive problem solving. So, how are all of us doing today?
Good.
Good, sir.
Great. So, before we actually start, hmm, I would want to have a quick sanity check on where we are in terms of project uh, identification, problem identification for our projects. So all of us have formed our teams. I know that we already have breakout rooms configured so that when we break out, we will go back as our teams. But I just wanted to get a kind of sense of what is happening in terms of the project. So I'm launching a quick poll and just 2 or 3 quick questions. I want to see your response on it. Okay. Are you able to see the questions?
Yes, sir.
Yeah, please respond. Yeah, let's quickly respond. I'm waiting for 3 more people to respond. Quickly, let's do that. So all of you are able to see the poll? Anyone who is not able to see the poll? I'm closing the poll in another 10 seconds. Okay. So are you able to see the results? I'm happy that a good percentage of you actually met. So I'm assuming 70% of the 12 teams met when we went there. And about 1/3 of the class has identified the project or the product that they would want to work on. And others have, another 1/3, a significant 1/3 or even for 37% has zeroed in on 2 to 3 ideas. Okay. So I would say you are also close to deciding. So that, oh, interesting. So that 70% of the class that met, I assume that 70% of the class has zeroed in on those ideas. Okay. The remaining 30% are nowhere close. Okay. And interestingly, 15% are excited to take it further. So they have one idea in mind probably, and they are raring to just go and take it further. 34% are still tentative. Okay, we are just waiting to see how to take it further. And remaining, 45% something are still in the process of finalizing. Okay, so thank you guys. Thank you for this quick drip test. It helps me to understand where we are coming from. So what is happening? Why, like I understand 70% of the people met, 70% of the teams met, Why did the other teams not meet? I really wish to understand. What is happening?
Maybe because they have already finalized their topic, so they didn't had a need to
So
meet.
ऐसा नहीं दिख रहा है मुझे सौरभ, because what I noticed was that 70% of the people met, and it is only 70% total who have either zeroed in on an idea or are at 2 or 3 ideas. It is almost the same number. 30% have not met, and 30% who are in the range of 4 to 6 ideas or no clue.
So, but there are also almost 34% who have decided their topic. So maybe
Yeah, so
mostly
70%
those
people
are the
met.
people who are.
So सौरभ, उनका सवाल नहीं है, मेरा ये सवाल है जो 30% लोग नहीं मिले, वो क्यों नहीं मिले? I am confident and I'm almost sure that during the class last time, hardly anyone would have zeroed in on one idea. There clearly was a need to meet again. Last time, we were just forming teams. We were just doing that forming exercise.
Yes, sir. Most probably.
So those who could not meet, why did you not meet? This is an important thing because we are starting with some aspects of the course today where if you know what product or idea you're working on, you will implement it and you will learn it in a particular way. If you've not done that homework, which was so important there, you will be just doing it as an academic exercise. This meeting would not have taken more than half an hour to at most 1 hour. Okay, I let you guys decide your, how you want to take this course. I cannot do that for you, but what I can definitely tell you from my experiences that if you do not have a clue of what you are going to work on, the learning in the lectures would also be restricted. I am taking it reasonably slow till now. Today we will pick up pace, and if you're not there to run with me, it's going to be slightly difficult. Okay. Can't cry over spilled milk, but if there is in any way I can help you, I would be happy to help you. I'm not sure how the office hours of other students, other TAs are being attended, but I do not have much footfall in my office hours. Like, is there a specific reason around that? Do you want me to change my office hours? I would be willing to do that, but I'm actually willing to help you, but only when you ask for it. If little things you do not do, then my capacity to help would also get limited, and how much I can help will also get limited. So is there any constraint around my office hours? They are Monday 3:30 to 4:30 p.m. This is at an intersection of 2 classes seemingly, so should not be a botheration per se, but does anyone have a constraint around it?
No, sir, not for me particularly.
Okay. So again, I am available and I welcome you to my office hours. Make best use of them. If you need any help, any just sounding of your ideas that, okay, this is the idea we want to work on. Do you think this is good, or anything, because we'll be doing learning some new tools now, which are process oriented. And it is important that we choose the right products. It is important that our learning goes in the right way. So if there is anything that you think I can help you with, please don't hesitate to join my office hours. And even for the TA office hours, they are available. They have done the course. Almost all of them have done the course earlier, so they know all these tools well. So this is a resource available to you. If you do not utilize it, that's your choice. Okay. So Let's start with today's session then. I will reiterate the office hour timings of the various TAs there. Abhinav's office hour timings I'm yet to confirm. So the total number of TAs in the course have reduced because of this shopping period, I would say. Abhinav's office hour timings I'm yet to confirm, but my office hour timings are Monday. Amir's are Wednesday. Soumya and Ribhav are available on Fridays. Okay, and if you are interested to use the tools that we are talking about in the course in your research projects, in your BTV projects and tech projects or wherever, we can also meet separately to exactly discuss the problem statement in your project and how to apply these tools. But these office hours are on demand. There is no fixed hour that we will meet. If you need help, you can just reach out to me on email and I would be happy to set up a meeting at a common time. Okay. So today we are going to another aspect of problem identification. So tell me one thing. Do you remember what are the 3 stages of innovation that we are talking about? Three stages of idea generation, innovation, substantiation that you were talking about in the previous class, or even in the first section on TRIZ that we took.
Problem identification.
Yes, problem identification.
Problem solving.
So problem identification, problem solving, and the third stage?
Concept substantiation.
Concept substantiation. Yes. So as you know, we are just starting with our project. So I am exposing you to different methods of problem identification. So in the last class, we had done cause-effect chain analysis. And when we did the cause-effect chain analysis, we had identified 2 or 3 problems. Then you guys met separately and reflected on which problem excites all of you most, and you chose one problem there. Today we will look at another aspect of problem identification, which is called function analysis. So why is this problem identification stage important? As a creative person, as a entrepreneur, why is this stage important? The problem identification stage. What are we trying to do in this stage? Hello?
So trying to identify what are the fundamental cause of a particular problem so that we could further evolve into solving of that.
Okay, so in the cause effect chain analysis, that is what we did. We looked at the root cause of the problem. And when we built those chains, we were able to look at all the different problem statements that we could solve to solve the final, to solve the initial disadvantage, to take care of the initial disadvantage. So in a sense, what we are trying to do is that, okay, this is my initial disadvantage. This is a symptomatic problem. This is what I'm seeing as an outcome of some deficiency, something somewhere. And while I need to solve this, I need to, it may be an overwhelming problem, a very big problem at that. But when I look at these cause-effect chains, I know that, okay, the same problem can be solved by solving something which is much simpler deep down there in the chain. So instead of solving a big complex problem, which could be very costly to solve, I'm solving something which is much smaller. So it is something similar that we are going to try with function analysis and trimming and stuff like that. What we are saying is that now if we have identified a product, or if you have identified something in terms of a problem to solve, a big problem to solve now, then let us do the function analysis. Let us look at what is happening in these engineering systems that we are intending to improve. So can you just give me a sample of the products or the ideas that you have that you would want to work on, product ideas that you want to work on in your projects? Can you just, a few of you, unmute yourself and give me a sample of those ideas that you are zeroed in on or are considering?
So air pollution in North India, cleaning up the smoke chamber during October.
So that is the theme. What is the problem? The cause effect chain analysis, what is the problem that you chose?
So we have actually as of now there are three problems: vehicular pollution all around the year, farm fires, and firecrackers during Dussehra and Diwali, something like that.
Okay, again, see, these are again initial disadvantages only. What is the problem? What is the product that you will work on?
Sir, we haven't yet proceeded much in that.
So you've not really done the cause effect chain analysis. Okay. Other teams?
So basically, for this only, so in particular for farm fire aspect, we can in particular build some certain tools which can, basically reduce the cost of operation of that cleaning that
Okay.
stubbles.
So you want to work on a tool that would, so you want to create a tool or have a modification in some existing tools so that the cost of cutting the stubble is reduced.
Yes, sir.
Okay, great. So now it means that we are talking about one product there. That, let us say, the appendage to the tractor, that you would just add it and it will help you clean the stubble.
Yes, sir.
Okay. What else?
Sir, also I would just like to add something. So in the vehicular population or pollution all around the year, so we have identified that this is one reason that there is slow adoption of electric vehicles. So if something could be done so that manufacturers are subsidized by the government, and
What is the
something.
product, Debajit? Is the product electric vehicle? What is the product that you want to work on?
Sir, electric vehicles.
Electric vehicles. So electric vehicle would have a product, and what is the kind of problem that you want to solve? Do you want to reduce its cost? So from what you said, it looks like that because you are asking for subsidies. So basically you want to reduce its cost. So government jo karegi, how to reduce the cost of an electric vehicle? That is your problem statement then.
Yeah, sir, to be specific, technology is like not still mature enough to be going for a cheaper mass production. So to facilitate its cheaper mass production, something like that we want to
Yeah.
work on.
What would you do? What
Uh,
technology do you want to work on? What technology do you want to innovate on to make it cheaper? An electric car would have hundreds of technologies involved in it. Which is one that you want to focus on? You cannot really focus on all the technologies related to an electric car, na?
yes, sir.
Are you getting it?
Yes, sir. Yes, sir.
So not really identified one little thing yet. So look at it like this. If I ask you to have a startup, see the idea that Rajat talked about, I could still think of a startup where we could manufacture or we could modify or we could do something to that one tool, and that startup is doing that. The problem statement that you're telling me, what is the work that your startup will do? If you as a project team have to work on it, what is the work that you will do? That is not clear yet. Are you able to see where I am coming from?
Yes, sir.
So you need to spend more time on the problem statement then. Cause effect chain analysis. Okay. Other ideas, please. So Pranay is saying simplifying laws for layman. So what is the product, Pranay, there?
So, sir, we haven't thought about the solution and the product. We were actually just trying to identify the problem and get into the root of it.
Yeah. So what is the root cause of the problem of this laws being so complex?
There are multiple. So,
So which one do you want to
lack
work on? Please.
Oh, yeah. Yeah, we haven't decided that yet.
So you were giving some examples of the root causes.
Right. So some examples are such that there's a lack of awareness and interest for the people to know about the problem. Then there is
Mhm.
lack of resources, such as the law books are expensive, and they that the available resources like they are just inaccessible in a lot of ways. And
Mhm.
there's also root problems such as there are a lot of language barriers, and there are low literacy rates,
Mhm.
etc. Yeah.
Yeah. So okay, these are all generic yet. No product you have
Right.
in mind yet. Hmm? Okay.
That is, I actually want to ask this: do we have to think about an idea which has to be made a product, or a profitable startup? What are we exactly doing here?
Yeah. So we are looking at something that we would pitch in the final project presentation. There is a pitch that we are looking at.
All right. So does that just have to be a solution to a problem, or does that have to be a product that has to be profitable?
Um, if it is a solution to a problem, a solution would work only if it makes financial sense. No?
I mean, so a solution could also be in a way that something that we cannot do, but we can suggest to the
No.
government.
No.
And
I'm not
so
looking
we're
for
looking,
suggestions. No.
all right. So we're
सजेशंस के लिए
looking for,
बहुत सारे लोग बैठे हैं, बहुत लोग बैठे हैं सजेशंस के लिए. We are not looking at that here. We are engineers. We are engineers. We are entrepreneurs. We are the future. We are not
okay,
just
so we
giving
have to
suggestions. We are proposing solutions. We are giving solutions, not just proposing. I'm not giving. We are not telling others to do something. We have to do something to solve the problem. We are solving the problem.
Right. Okay, got it.
Okay.
So if we like take upon like a problem which we believe that we can, so you are saying basically we shouldn't take upon a problem which we cannot give the solution to completely ourselves. Like if we take upon a problem that we can give ki, like, okay, this is like the driving force, like this is how you could do it, like the all the aspects of it, and tell like, okay, this aspect would require this much, this aspect would require this much. If it is implemented, that is not
No,
required here, but
we don't
rather
want to
like
do this kind of a study, Lavanya. So then
okay,
what you're saying is this is a study that we did. No, I'm not
yeah,
looking at a study.
okay,
I'm looking at a solution.
got it.
हमें औरों को देख के नहीं बताना है कि तुम ऐसे बदलो. That is not the intent. हमें solution देना है. The problem है, as an inventor, as an engineer, what is the solution there?
Yeah, right.
लोगों का behavior वही है जो है.
No, no, so I wasn't talking about the behavior of the thing, but I was like, because this layman solving the laws for the layman was the idea we are doing together. So in that we right now what we were doing, we identified all the root causes of it, why people why it's not being implemented yet. Because the NITI Aayog has been trying to do it, but what they have done is they have just made a repository where they have compiled all the laws. It isn't helping any normal layman to do that.
So now अब यहाँ पे root cause analysis करो कि वो repository है, why is it not
Uh,
helping the layman?
Yeah, so we did that. Okay. So we did that, and the major causes that we found were like the laws are in itself filled with jargon, unnecessary jargon, completely like primary use and like random words that are just thrown there, which only a lawyer could understand. That was one main cause. The second main cause is like the laws are updated, and when they are updated, they take a lot of resources, lot of manpower. And when they are updated, the new books where they're updated in, they are not in circulation. So even if a person tries to go out of his way to try and find the law that they're trying to find, they would only find the outdated law. They would not be able to find the real law. So we were trying to do a cause effect on this, and we were able to find out around 10, 15 different problems and like root causes of those like 2, 3 main problems. But then this was what we did till now. Now, as you are saying that we need to pitch a product. So in this scenario, do you think that like we could pitch a product for like a specific cause, like on a
Yeah.
very specific thing, or like because I think the problem right now with us is we are trying to see the whole problem as together and just trying to see ki, like even though we are not thinking of the solution right now, but even if we are trying to see the whole problem as a whole, like okay, going forward, what we would do to solve this entire problem. So you are saying we shouldn't focus on that because that would be like a study and we wouldn't be able to pitch a product completely. We should rather focus on a particular root cause and try to solve that and pitch a product for that. Right?
Yes, that was the intent of CECA.
Okay, got it.
That we identify which is the easiest thing to solve. For example, you just now, I'm just picking up on your words, Lavanya. This is not, I have not even looked
Yeah.
at your brainstorm and nothing. Huh?
Yeah.
Just picking up on what you shared just now. You just said that the laws get updated, but there is no way to track them.
Yeah.
Huh? So actually, do you realize that in terms of laws, the laws get updated not just by the executive. It is not that parliament कोई law pass करेगी तभी एक law update होगा.
Yeah.
A law is updated in almost every Supreme Court judgment, in almost every High Court judgment, in almost every ADJ court judgment. When a High Court says that this is how this particular statement in the Constitution has to be interpreted, that in itself is a modification of law.
Yeah.
It is a clarification of a law point. And there are websites like livelaw.in. There are softwares that lawyers use, that judges use to see what is the most recent case law around a topic.
Okay.
So there are in the market products which are solving exactly the same problem.
Okay.
So probably again, you looked at the problem. You did not look at what is existing in the market yet. Is this really a problem?
Yeah. We just reached the cause effect chain right
Is
now.
this really a
did
problem?
the analysis. Yeah.
Is this really a problem? So there are products in the market which kind of update. आप livelaw.in website पे जाएं on a daily basis.
Okay.
All the Supreme Court, High Court judgments that have come in the recent past, उनका कुछ ना कुछ summary update करा जाता है. So lawyers have to track it. It is their bread and butter. If they do not track it, how will they survive?
Yeah. So we were not thinking from a law perspective, though, na. We were thinking from a very layman perspective. Like,
But
I
see, the
didn't
problem
know
that
this.
you're telling me, the problem that you're telling me that the law, जो नीति आयोग ने law repository बनाई वो update नहीं होती, वो layman के लिए अच्छी है. But you have to see for whom is it the main parameter of value.
Okay.
किसके लिए main parameter of value है? Law की updated knowledge रखना.
Yeah.
एक lawyer के लिए और एक judge के लिए.
But
see, you pay to a lawyer simply because he is expected to do this.
Yeah, sir. But on a going day-to-day basis, like if I'm going to a marketplace, if I don't know my consumer rights. So in that scenario, you are not putting up a lawyer in the situation, right? You would like there would be a situation where you wouldn't even know that your rights have been violated. Reaching a lawyer is like a part of knowing the law that okay, something bad has happened with me which wasn't supposed to, that like which violated my rights, and then you reach the lawyer. I understand the point, like for that whole trial and everything, like only two people need to understand completely, which is the lawyer and the judge. But to reach that situation also, we need a normal layman to understand like the basics of it, no, like what is right now in the current and everything.
Right, I agree. So Lavanya, what we could think of is what product will help us bring that awareness. Don't just point at a problem that everyone is doing. That each one of us is also fed up of. ज्ञान तो सभी लोग दे देते हैं ना. We are inventors here. We find a solution to the problem. Okay.
Got it.
Any other product idea? So you see, if you guys have not met in the last 1 week, then your ideas would be all over the place. even if you have met, it can happen that your ideas are all over the place because you have not attended the office hours, you're not touched base with any of the TAs there. Is this mature enough? Can we proceed? That is why it is. See, why do you think we are, all of us, the TAs and me myself, sitting in that place, in that meeting room, waiting for you guys to come? Because we know it is not a simple topic. This requires discussion. This requires elaboration. This requires a brainstorm in itself. It is up to you to utilize this resource. So any other idea? Quick product idea?
So one more I could think of, because since the basic problem was a 15 days gap, that is between harvesting and between sowing of seeds of the wheat. So basically we want to increase this gap. So now to increase this gap, one more feasible idea, but that is agricultural based solution, but that is something hybrid kind of seeds. Likewise for paddy thing, it should ripe up early, and for the wheat thing, it should basically we can provide some more
It later.
Yes.
Yeah, but again, as an engineer, you can't solve this problem just yet.
Yes.
So we do not pick this up.
Yes.
So we pick up. So जो हमने cause effect analysis करा, या जो अभी हम आज function analysis शुरू करेंगे, we want to pick up something which we can solve.
Yes.
Okay, we are not looking at अच्छा तुम ऐसा कर लेना, या let those scientists do that research. Let them do their job. They already know what their job is. We are no ones to guide them. They are experts in their job. Is it not?
Yes.
So we focus on what we should do and what we can do.
Okay, sir.
So yes,
I had an idea. So, sir, if you look at entering a Web3 universe or a metaverse kind of a thing, you need to buy a crypto token and then transfer it to your own wallet to make any transaction or to enter the world. Now, if you see the current scenario, you need to buy the crypto from your fiat wallet or fiat currency from any exchange and then transfer it to a different wallet. Now, if you see on any Indian exchange, they have a huge withdrawal fee. If you withdraw from a crypto, like if you withdraw some token from your exchange wallet to your crypto wallet, like MetaMask or some other wallets, you have to pay a huge fee, like a 50 matic, 100 matic fee. And this creates a huge wall in between. Like any person who has no idea how this community works, how this environment works, he or she cannot enter this environment because of this huge entry barrier. So we are thinking to make an exchange where we don't have any withdrawal fee, and a person can easily enter the crypto environment and have a single wallet for all transactions.
Okay, yeah, that
is what we are thinking about.
Yeah, that's an interesting product. So we will also look at evolutionary trend analysis and other such stuff as we proceed, and you will see that some products will naturally follow a particular trend. So this trend to openness, open source, everything, that is a trend. So the product that you're proposing seems to be following that trend. However, what we should need to realize is that it is not just about technically following the trend. The trend analysis actually falls apart many times because of the customer perceptions of what is the main parameter of value, or legal issues. Okay, so just be careful around those aspects. But at a broad level, you are kind of following the trend of system evolution, of a computing system or a platform evolution. That platforms may start with independent private platforms, but will gradually, see, you observe this everywhere. They start with as individual private platforms, but then they become open. Many people can come and hop onto them, and they can easily do work on them. Cloud resources, everything, all that. So great. So what we are going to do today, we are going to start with what is called as function analysis. What is function analysis? So function analysis is an analytical tool that identifies functions, their characteristics, and the cost to the system and the super system components. Okay, so function analysis is a tool to kind of break up your engineering system or product and understand it better. Why is it necessary? It is something like root cause analysis. Okay, there is this problem that I see. What is causing this problem to happen? So you're looking at now, once you've broken up the product, opened it up, it's something like, your car has stopped to work. You go to the front, you open the bonnet, and you now look into various places. Okay, are the battery terminals clipped? Is there sufficient coolant in there? Is my engine, the plugs there are correctly there? There is no soot in the plugs, and so on. So now, once you know that these are the various components, you check each of those components one by one and debug and get your car to start again, all over again. So function analysis is a way so that we can look at any system in an analytical way, in a detailed way, and then see where the problem is. And instead of that big problem or simply a symptom of a problem, we solve that little component problem there. Okay, so just like in cause effect chain analysis, we looked at a whole range of reasons why a problem was happening. Over here, again, we are looking at different components and seeing which component is causing the problem there. Okay, and then we do something only to that one component or two components, and the remaining system can remain same. Or we could do something to the entire system. We will look at that, not today, probably in the next class. And we could come up with a different set of solutions. Okay, so there are 3 stages of function analysis. First stage is component analysis. That is identifying the components of the engineering system and its super system. So you say that your car just conked off. You were driving, you stopped at a traffic signal, and after that your car just doesn't start. So where could be the problem? The first thing that you need to look at is, okay, what all is there in the car? That is the component analysis. Okay, there is an engine, there is transmission, there are wheels, there is a fuel tank. So there are so many things that a car has. There is a body, there is a braking system, so many things. So you identify these components and you say and then you look at how are these components interacting between them, amongst themselves. So is the braking system interacting with the engine? No. The braking system, however, is interacting with the wheels. Is the engine interacting with the transmission? Yes. Is the engine interacting with the fuel tank? Yes. So if there is a problem in the fuel tank, then it can lead to a problem in the engine. And therefore the car may not work. The car may not start. If there is a problem in the transmission, even if the car starts, the engine is functioning, but it will not move. So there could be so many different reasons why the car has stopped. And when you understand the components and their interactions, you can now make some sense out of where to work on, how to solve the problem. The third step is identifying and evaluating functions that are being performed on the components. That, okay, can the braking system fail because of engine? No, these two are not even interacting. But can the braking system not work because something has happened to the wheel? Probably yes, because they are interacting with each other. So now we say, how do the braking system and the wheel interact? And we also analyze, is this interaction healthy? Is this interaction normal? Or are the brakes getting applied a bit too much, which is leading to loss of fuel efficiency, let us say. So these are 3 stages of function analysis: component analysis, interaction analysis, and then function modeling. So when we look at component analysis, what we are essentially trying to do is identifying the components of an engineering system. And I would say not all components, but relevant components of an engineering system and its super system. So what is an engineering system and what is a super system? What do you understand by these two terms? I have not described them, I have not explained them, but if I am using these terms in this context, what do you understand of them? It's a question. What do you understand by the term engineering system or super system?
So engineering system means like those components who are like, let's say there is a product and there is like some part of the product which are used in or like engineering things actually. So within that engineering system, there is some components is there. For example, if you consider, for example, a drone, then a drone is like you are using its fan and everything, like all the IC and everything. So those are part of the engineering system, but it's not in final product. But if you consider super things means it's the entire product you're going to talk about. It's all the hardware and software, like everything is like going to combine actually.
Okay.
Like,
yeah, thank you, Biman. You're taking us closer to the answer. Anyone else?
So basically, if we talk about some medical product, so here what a machine involves is the basically an engineering system, and how a machine responds to a particular medical case, that involves the complete basically involves a medical system also. So in a whole, we can talk it as a super system, but where the machinery part is there, we can basically call it engineering system.
Okay, good. More ideas?
Hello, sir. Sir, if we talk about how hydroelectricity is generated, then it consists of turbine and which is connected to a means AC synchronous motor. So that there is a mechanical system as well as a electrical system, but combined whole system is acting as a engineering system, something like that.
Okay. And what is a super system? So Vrinda is saying super system is something that involves the environment or external interactions. Thank you, Vrinda. This actually does take us forward. What else?
So maybe super system involves all the components interacting with the actual system as well and how they are affecting.
Okay. So let's take the example of that extra appendage for the tractor, which could be, so over there, that extra that appendage that you want to work on, or that plow, or that harvester that we want to work on, that is the engineering system. Okay. And the crop, the stubble that needs to be cut, the ground on which the tractor would move, the person who will drive the tractor, all that is the super system. The engineering system is a product which you can possibly go and purchase, that you're going to offer. Super system is the context and other people and everything else around in which the product would be used. Other interactions that are happening there also form a part of super system there. Okay. So what we are saying is that the component analysis, we first identify the components of an engineering system and then also of the super system. For example, this drone would be carrying a payload. That payload is a part of super system. It would be rising up in the air. So air is a part of super system. Can your drone function in vacuum? No, it does require air, but you don't need to sell air along with the drone. The air is available in the super system. Are you able to see this? Is the distinction between engineering system and super system clear now?
Yes.
So please explain it once again.
Okay. So whatever product you want to update. That product, let us say, is the engineering system. So we wanted to make a drone. So the body of the skeleton of the drone, the blades of the propellers, the remote, the wires, the display, the connecting stuff, everything, they are all a part of the engineering system. Now you are making this drone for a particular purpose. You want to, for example, capture images of a particular landscape. Now that landscape is now the super system. Air, because just to take a lift, you will need air. Otherwise, the drone cannot fly. So air is a part of super system. So something that you're making that you will sell to the customer as a product is the engineering system. Other things that the customer may already have or may add or may anyway pervasively exist are a part of the super system. That is the context in which your engineering system is operating. Clear? Any
Yes,
questions?
Yes, sir.
Okay. So we identify system and super system components. And these components could be two things, could be substances or fields. So substance समझ में आता है, they are objects with a rest mass. So when I showed that drone, in that drone, I was showing the substances as the blades, the wires, the battery and everything. And what we are saying is, when we are identifying these components, we should also identify fields that are there due to these components and with which the engineering system is interacting. For example, in the context of a drone, what field would be there?
So gravity.
Gravity. In terms of a magnet, that field is the magnetic field there. Abhi, he was talking about hydroelectricity. So the magnet that is there in the synchronous motor, you can actually talk about that, because when you talk about the magnet, when you talk about how it is interacting with the with how that mutual inductance is coming into picture and so on, only then you will be able to improve the synchronous motor there. So when you talk of engineering systems, you talk of two types of components, those which are substances and those which are fields. Now, how to do the component analysis? So the first step in component analysis is creating a hierarchy of components. For example, when we were talking about the car just a little while back, we said a car would have wheels, the car would have its body, the car would have its engine, it would have a fuel tank, it would have this. So these are components at one level of hierarchy. Now, I could also say that the engine of the car has a chamber, it has a piston, it has an electric plug, it has valves, it has so many things. Do you realize that when I talk of the components of a car, I did not talk about the valves inside the engine? Because when I'm talking about the car and identifying which part of the car is faulty, I want to look at the components at the hierarchy of the car only. Once I identified that the engine is faulty, that is when I'll go deep and say, what are the components of the engine? Now, even in this, I may go and say, what are the components of the transmission? And I could say, okay, there is a rod, there is a cantilever, there is this, there are 4 nuts, there is this kind of a thing, and they will become a lower hierarchy of components. So we create a hierarchy of components. What hierarchy are we looking at? Are we looking at the full car, the components of the car, or sub-components of those components? Okay, we select where we are working at and then identify the components at the selected hierarchical level. I will give you an example. Car, At the second level, there are electrical. So when I say of a car, I say, okay, there is electrical system, there is a steering system, there is a fuel system. Now, I may say that electrical system has an alternator, a voltage regulator, and a battery in it. And then I could say that the battery has electrodes, electrolytes, and casing. And now, whichever level I want to work on, I can do component analysis at that level. When I'm talking of component analysis at the electrical system level, I will talk only of alternator, starter, voltage regulator, battery, and so on. I will not talk about electrodes of the battery in the same component analysis. I will not talk about the transistors inside the voltage regulator in the same analysis. Are you able to see this? Any questions? Clear?
Yes, sir.
Yes, sir.
Great. So, natural question is, how do I select the right hierarchical level? So, you select the level based on project goals and constraints. A lower hierarchical level increases the analysis effort, but a higher hierarchical level may have only insufficient information, so you will not be able to solve the problem. For example, if you look at the case of this law wala system, that Lavanya was talking about. If you look at that case, at present, they're at a very high hierarchical level. They're just saying Niti Aayog, they're just saying public, they're just saying this. So it doesn't have sufficient information. Where is the system failing? You need to go slightly deeper. You go to a lower hierarchical level and see where is the system failing. Only then you will be able to solve the problem. Again, as I already mentioned, you have to ensure that you select components at the same hierarchical level only. You cannot have alternator and electrodes of a battery in the same component analysis. Okay. Now, when I say electrodes of a battery, how many of you have actually opened up a car bonnet and looked at the battery? Or why just a car bonnet? Many of you may have those inverters at your home and battery associated with it. How many of you have looked at the battery? Do you know how many cells are there in a battery?
So around 8.
Yeah, could be from 6 to 12 also, depending on what is the capacity of the battery. So now I could say that all these electrodes or all these cells are exactly the same, and therefore I want to put them as only one. Okay, so there are cells in the battery. Or I could say that I am using 12 cells. So cell 1, cell 2, cell 3, cell 4, and so on. For example, if there are 6 nuts that are used in a system, you could say there's just nuts, or you could say 6 nuts. Why? Because the goal is to save costs, and reducing the number of nuts could be a solution. In case of a battery, reducing the number of cells could be a solution, and therefore you would want to say put all the 12 cells separately in your component analysis. And okay, if you realize that, the hierarchy at which I did my component analysis, I still do not know sufficiently enough as to which component to work on or what problem to solve, go back to the drafting table and do the component analysis at a still lower level of hierarchy. Okay. Is it clear till here? Because now I want to take you through an example, and then we will do some exercise ourselves. Any questions still here? Okay. So now let's look at the example of a paint filling system. Now there is this paint filling system that is designed to start filling the paint in the tank. So you see this tank? There is this tank over here, which is holding this yellow colored paint. And the paint filling system does that, or what this paint filling system does it, that as soon as it senses that the paint has, the level of the paint has reduced, it would start to refill the paint. So this the entire factory floor has these radiators of the cars. The radiators come on a belt, they get lowered into the paint, and they get dipped in the paint they remain dipped in the paint for some time, and then they're pulled out. Okay, so as the radiators move from this side to the other, they get painted. Okay, and there is this tank in which there is paint. The radiators dip into this tank, and that is how the painting process happens. Now, if I want to do component analysis, okay, so why am I talking about this engineering system? There is a problem. The problem that this manufacturer was facing was, it's a very simple way to paint the radiators. The only problem that this guy was facing was that, you see, there is this float here. So all of us would have some water tanks on our roofs, on the roofs of our houses. How many of you have gone and cleaned those water tanks ever? Or even just opened them and checked them out ever?
So I've checked them maybe once or twice, but
yeah, we've seen them, huh? Okay.
yes.
Anyone who's not seen them ever? Never opened this water tank? पता नहीं पानी जादू से हमारे taps में आ जाता है. Anyone of that kind category here yet? No, there's no problem. I'm just checking if I introduce these floats in a particular way, will you understand or not? So if you have seen those tanks, so all of you have seen those tanks, what do you see? There is a ball there. At the end of the ball, there's a ball and there is a lever. And as the water level rises, this lever goes up, like it goes like this and closes the tap. So your water tank doesn't overflow. Have you seen that? The ball inside your water tank?
Yes.
So the same system they had applied in this place also. They said we will have a float. This float would rise as the level of the paint rises. So as the level of the paint rises from, say, this level to this level, the float would also rise. And as the float rises, I have kept a lever there which will turn off the switch here. Now what happens is, over time, this float starts to get paint solidified on it. So paint is usually thick, and when it interacts with air, it would solidify. So when such a thing happens, the float becomes heavy. The float becomes heavy means it will not rise as much as it used to when it was light. And in the process, paint overflows from this tank. When the paint overflows, there's a big problem. The problem is that the shaft floor has to be, the production has to be stopped. The shaft floor has to be cleaned. There is paint all over the place. You have to also use additional material. So there is additional cost. So there is loss in multiple ways. First, your production stopped, so time loss. Then, the system needs to be cleaned up. Everything needs to be cleaned up. Material lost. More labor needs to be invested. So many things. So there's losses. And it's not desirable. Especially the production, stopping the production is definitely not desirable. So this problem needs to be solved. But to solve this problem, the first thing that we need to do is component analysis. So we list down what are the components of this engineering system. So this is the problem that I just explained to you. And we want to solve this problem, but the factory owner said that I do not want complex approaches. I do not want to use sensors because of high cost and so on. Somehow improve this system so that with minimum changes, I'm able to work. So this is our paint filling system in a little zoomed fashion. And if I do the component analysis, the engineering system is paint filling system. The components of this system are float, lever, switch, motor, pump, and barrel. And what are the super system components? Paint. When you brought the engineering system, paint did not come with it. You filled the paint. The paint is a super system component. The tank did not come with it. I'm just talking about float, lever, something to switch off the motor there, something to stop pumping more paint into the tank. Paint, tank, the radiators, air and gravity, they are not specific that you manufacture and you gave to your customer there. So they are the super system components. Let's look at another example. Hair dryer. Many of you may have used a hair dryer, seen a hair dryer at your home. So what are the components here? So when you look at it, you say that the components, the engineering system is hair dryer, and components I'm looking at are body, power cord, heating element, fan, nozzle, motor, handle. What are the super system components? Air, user who holds the hair dryer in his or her hand. Water, because water is what needs to be removed. And here, they did not come with the hair dryer. You had your hair with you when you went and purchased the hair dryer. So here is also super system component. You could list down many more super system components also, but these are the most relevant ones. Are you able to see this?
Yes, sir.
Any questions? Great. So component analysis is fairly simple. What we have done is, when we talked about component analysis, we talked about what a component is, an object that constitutes a part of the engineering system or super system. Engineering system is a system that has been assigned to perform a function. Field is an entity without rest mass. Substance is an object with rest mass. And super system is a system that contains the analyzed engineering system as a component. In that factory, so things around that, this shaft floor on which the painting of these radiators was happening is the super system. Because in this super system, the paint filling system is the component. Okay. The other components of the super system are, as we discussed, air, gravity, radiators, the parts that need to be painted, the paint, and so on. Okay. Now, once we identify the components, the next thing that we talked about was we want to see which components interact with each other. Because if, as we said, if the transmission of the car is not interacting with the, let us say, the headlights, then the possibility that the transmission is faulty and that leads to failure in the headlights is almost zero. Is it not? A headlight interacts with the battery, with the wire. So a failure in the wire could lead to the headlight not turning on, but not the transmission system. So I don't want to waste my energy in, so these sound like very simple and obvious things to talk about. And they are. But they are so because I'm actually choosing simple engineering systems that you know of on a day-to-day basis to communicate my message. When you will work on the real problems, all of you have identified some problems for yourself, you will see that if you do not know sufficiently about the problem, looking at this interaction analysis will help save lots of energy, time, and resources from undesired or places where there was no solution in the first place. Okay. So what does interaction analysis involve? So interaction analysis is used to identify the interactions of components of an engineering system with each other and with the components of the super system. For example, the wheels interact with the road. Because wheels interact with the road, that is why a car is able to move. If the wheels are not in touch with the road, would the car be able to move? So components of the super system which are necessary, which are relevant to the problem statement at hand, should also be identified, and interactions with them should be listed. And when we say interaction, one thing that we need to kind of assume as a fundamental is, we will say there is an interaction between two components only and only if these two components physically touch each other or touch each other through a field. Okay, either there's a physical touch or there is a field through which you're touching them, and you have not listed that field as a component yet. Okay, so unless there is this touch, you cannot say there is interaction happening. Okay, so what we do in interaction analysis is we list down all the components of the system, the way we had just analyzed all the components of this engineering system and the super system. So it could be that these three are the engineering system components and these two are the super system components. So we list down all of them in this fashion. And then wherever the components touch each other, for example, I say component 1 touches component 3, I put a plus sign there. Component 2 also touches component 3, I put a plus sign there. And then you will notice that when it comes to component 3, because component 1 was touching component 3, you will put a plus here. So do you notice that this matrix will finally come out to be symmetric along this axis? Huh? Because
Yes, sir.
if component A touches component B, then component B is also touching component A.
Yes, sir.
So this is a sanity check that we do when we do component analysis. If component 1 is not touching component 4, there cannot be any action, there cannot be any function, that is the third stage, between those two components. So this interaction analysis helps us identify all the unique functions or all the functions that there could be in an ecosystem. Wherever there is a minus sign here, we don't even need to analyze if there is a function there. There cannot be. So when I will go to the next stage of modeling, I know that there can at most be, let us say, these 5 interactions are happening. So there could at most be 5 into 2 or 3, as many interactions or functions. These will not contribute to any functions in the engineering system. We'll just look at what the functions are. Okay, but interaction analysis means that there is an interaction, that these two components are touching each other. These plus sign means the two components are touching each other. Okay, so if we look at this paint filling system and do the interaction analysis, you will see that it will appear something like this. The float is touching only the lever. It is the lever that is touching the switch. And lever is touching the tank also. The lever is touching the air also. The lever is not touching anything else. So there is no other plus in this row, the row of the lever. Pick up any component, let us say barrel. Barrel is not touching the float, it's not touching the lever, it is not touching the switch, it is not touching the motor, but the barrel is touching the pump. The barrel is touching the paint. Barrel is not even touching the tank. It's not touching the parts. But yes, it is in touch with air. You see, this is the barrel. Barrel is touching the pump. It is touching the paint. It is touching the air, but it's not touching the parts. It's not touching the tank. Huh? So you just put pluses over here. So this looks like a very mundane thing, but let me assure you, when you have lots of components and you're doing a system analysis, this actually cuts down all these additional analysis that you would have otherwise been bothered about in identifying the most optimal solution. So you're being smart. You're only looking at places where there is an opportunity of a solution. And that is where this interaction matrix, this interaction analysis is important. Okay. So when we talk of interaction analysis, we're talking of making an interaction matrix which identifies all the interactions that are happening between various components of the engineering system and its super system. Any questions till now? So when you will do, for example, Rajat, you talking about that extra appendix to the
yes, sir. Tooling
to the tractor, you have to clearly identify what are the components of this. There is a component of blade, there is a component of the bar on which this blade would be held. So, and then you see what is happening. Or you say, okay, let me improve the existing harvester appendage that already is there.
Yes.
So you list down the components of that, and you will see, okay, in that the stubble is a super system component.
Yes.
Huh? That the what do you say, the soil on which the tractor would run is a super system component.
Yes.
So all those things you can list down as components and super system components.
Yes.
And then you put a plus there. Does the tractor touch the stubble? Yes, it does, because that is what it moves on.
Yes.
And the first the tractor moves, and then the blade comes.
Yes.
Does the blade touch the stubble? Yes, it does. But does the bar of the blade on which the blade is resting or connected touch the stubble? No, it does not. Okay, so you need to do this interaction analysis for the product that you're working on.
Yes.
After we have done the interaction analysis, we go to the final step, which is called as function modeling. Now is where we will start to identify which function is not working well, because of which the problem is appearing. Okay, so function modeling is the stage in function analysis where a function model of the analyzed system is built, and the function model describes the functions, their usefulness, performance level, and costs at the system and the super system components. So we're talking about functions, why they are important. Are these functions happening or being done at the level that is desired? And what is the cost of getting these functions happening in the first place? Because unless you know about the costs, if you propose a solution, that solution may not really work, because you propose a solution which increase the cost of the entire super system or of the engineering system 5 times. So there is a solution, but that's not really a solution. People will not pay 5 times the money to solve a problem, probably, unless that problem is actually the main parameter of value. Are you able to see this? Why all the 4 things are important?
Yes.
So Pranay is asking, is this useful in software applications also? Yes. In software applications, for example, you may have one function, second function. So over there you have these modules that you may have defined, and those modules are interacting amongst each other. And you realize that your software is running slow because of 1 or 2 of those interactions between those modules. Are you able to see this, Pranay? So this analysis can also be done on the software systems. It is not restricted to only mechanical or electrical systems there. Okay. Now, what is a function? We say that in the function modeling part, we will identify all the functions in a system. So what is a function? A function is an action performed by one component to change or maintain a parameter of another component. For example, flame, one component, heats burgers. So what parameter of the burgers has the flame changed? The temperature. Huh? So flame heats burgers is a function, where flame, which is the actor, is called function carrier, and burgers would be object of the function, the component whose parameter has been modified or maintained. Okay. So conditions for existence of a function, as we already discussed, that they should have an interaction. And if we are talking of a function in an engineering system, the function carrier and the object both should be components of the engineering system. So first, function carrier and object are components of the engineering system, and then function carrier interacts with the object of the function. Unless this happens, there is no function happening. So, and third is that some parameter of the object of the function should either change or be maintained as a result of that interaction. So these three conditions have to be met to say that there is a function there. If any of these three conditions is not met, then you say there is no function. Okay. So, for example, hammer moves the nail. So what is the function carrier over here? What is the function carrier over here?
It's a hammer.
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 What is the object of the function?
Nail.
Nail.
And what parameter has changed?
Position.
Position of the nail has changed. So some parameter has also changed. So this is a valid function. Okay. Now, what is the function of an open door?
Let anyone in.
Yes, sir, to let anyone enter the room.
So let a child enter the room. So what is the function carrier over here?
Door.
So the hinges.
Hinges, okay. Or door, okay. What is the object of the function? Huh? People. The child, huh? So is there an interaction happening? Is the child touching the hinge?
No, if it is open.
If it is not open, then he has to.
Yeah, but as of now, the child is not touching the hinge nor the door. So can there be a function here? So an open door does not have any function. A closed door has a function. So you said to allow a person in. They are nothing. There's no function between the open door and the running person because there is no interaction between them. Okay. Are you able to see this?
Yes.
Now, what is the function of a helmet? This is a soldier wearing a helmet, and there is someone attacking the soldier. So what is the function of a helmet?
So to prevent
protect.
head injury.
So what is the function? What is the function carrier?
Mm. So in case of soldiers, maybe.
Huh? Helmet is the
So the
function
material
carrier.
of the
So helmet is the function carrier. What is the object of the function?
Head.
The head of the soldier. Huh? So what parameter of the head has changed?
Safety.
So
Safety.
it's maintained. The safety is maintained of the head. I think.
Safety is enhanced.
So when you define functions in your engineering systems, how will you define safety is enhanced? Is there a metric of safety is enhanced? Is there a number you can give? No. So when you define such a function, it will not help you in any way. So when we talk of function modeling, we never define declarative functions. We never say that to protect the head, to save the soldier, to provide safety. No. We never say this. What we say is the function is to deflect or to stop the bullet. Do you see this? Because when you say to provide safety, now what, as an engineer, what would you work on it? Can you do anything about it? Agar safety nahi mili to? No. But when you define a function like to deflect a bullet, now you can do something about it. Oh, it did not stop the bullet. Now, why did it not stop the bullet? Now you can do something about it. But to save the soldier, oh, the helmet could not save the soldier. That's a declarative statement. As an engineer, it does not take you anywhere. So such declarative statements for functions are not allowed. Okay. Some parameter has to be changed or retained or maintained. Over here, the parameter is one, the direction of the bullet has changed or the velocity of the bullet has changed. Okay. So this is the next set of rules for defining functions. The first is interaction should happen. So those three rules should be met. They have to be components of the system or super system. Then we said there has to be an interaction. So open door has no function to perform. Then we said that we do not use declarative statements. Safety, protection, cleaning, all that, no. What is the function of a toothbrush? So there are these dirty teeth of a dinosaur. What does a toothbrush do? Sorry, I could not understand, Anuj. There was a crackling sound when you were speaking.
To wash it.
To wash it. Okay. Wash me. What is the object of the
Cleaning.
function? Cleaning. Abhi maine kaha ki we don't use declarative. So what is the object of this cleaning?
So scrubbing, can we say, like?
So scrubbing is an action. What is
To remove the dirt or germs.
Yeah. To remove the dirt, to kill the bacteria, to remove germs. They are the right functions. I'm so happy. You know, to clean teeth, to brighten teeth, no, nothing. The teeth look brighter because the plaque has been removed. The teeth are clean because I've removed the germs and plaque from it. To prevent cavities, all these are declarative statements. We cannot use them. We simply say to remove plaque, to remove food. That is what leads to all these, is it not? And if this is not happening well, you can do something about it. If you simply say a declarative statement, this toothbrush does not clean my teeth properly. Now, as an engineer, how would you solve the problem? Can you solve it? No. So that function, you can say it. It is English language. You can say it. But in an engineering term, it does not help us. So we do not use such declarative statements as functions. Okay. So we do not use negative formulations. We do not use declarative formulations, and we should be as specific as possible. If we cannot think of what parameter is changing, you can simply say X changes Y parameter of Z. Okay. And importantly, we document only consequential functions. For example, we say air cools coffee, not coffee heats the air. So when you are a customer, or when you are designing or making coffee, so you want to, or when you are delivering pizzas to the homes of your customers, you do not want lots of air to interact with your pizza because it would cool the pizza. So you have those bags in which the pizza delivery boy brings those pizzas to you. He's reduced the air contact. So it was a relevant function for which a solution was found. Now pizzas were heating the air. Is that a relevant function? Do you want to find a solution to it? No. But imagine you were given the task of air conditioning the Domino's outlet. Then something heating the air, will that be a relevant function?
Yeah.
Yes. So whether a function is consequential or inconsequential is very significantly dependent on what is the context, what is the problem that we are trying to solve. Okay. So I think let's stop here, and we will start from here tomorrow. And tomorrow we will then review, we will use the component analysis, the interaction analysis, and putting these functions in, we will also start to work on our problem that we have identified. So those teams who have not yet identified a problem, or who thought that they had identified a product but have not really done that yet, who were in a very vague state, कि हम suggestions देंगे. So please, I would suggest meet today, identify, zero in on the product, so that tomorrow when we start to do function analysis, function modeling of your system, you have the relevant inputs. Okay. Any questions? So Shana, we started the class at 1:30. We have had 1.5 hour class.
Oh, sorry, sir. I thought it started at 2:30. I joined late.
Okay. Okay, so we will start from here tomorrow.
Sir.
Yes.
Sir, office hour कब है sir? ये CIP.
3:30 onwards. My office hours are from 3:30 onwards.
Same link, na sir?
There is a separate Google Meet link that I have posted on the classroom. We will meet there.
Okay, sir.
Okay.
Thank you, sir.